For 5:30 to 6:15 for the first 45 minutes, Rakesh will be presenting his learnings about artificial intelligence. From 6:15 to 6:30, we have time for questions. So if you have any questions, you can type them down in the chat box. Given the large audience that we're expecting today, please keep your video and mic off to reduce stress on the bandwidth. Unmute it only when our speaker is taking questions and comments. So when you have to ask a question or you want to clarify something, please type them down in the chat box. So I'll be curating all those questions and comments throughout the webinar, and I'll be asking those questions to Mr. Rakesh. We also have Prerna from the implementation team, who is taking notes, a summary of which will also be circulated to all of you after the webinar. So this webinar will be recorded and will be available on YouTube and Firki website very soon. Thank you so much for listening to me for this while. That brings me to the end of my introduction. So let's now move on to webinar. And I'm handing over the space to Rakesh. Thank you so much, Rakesh, for joining today. So you can take it forward from here.
Thank you, Elizabeth. Welcome, everyone. Thank you for having me in this platform. I would especially like to extend my thanks to Prerna and Elizabeth, who tried to explain the entire platform to me and how to get here to present in front of you guys. And I thank Firki for giving me the opportunity to share some of my thoughts. And I'll now directly go to the presentation. Oh, okay. By the way, how do I share? There is a host disabled participant screen sharing, it seems.
Rakesh, there is a button below on the left side where share screen. Can you see that?
Left side where there is a button.
It's share your screen.
So when I click on the share, it says that the host disabled participant screen sharing.
So Ashwath will take care of it. 1 sec, okay?
Yeah.
So as Ashwath is figuring that out, I'm just introducing the different participants today here. We have Meenu, she's a second-year fellow at TFI Bangalore. We have Rahul Gomes, he works as a course designer at Firki. We have Akshay from TFI Ahmedabad, Yasin from Manipur, Guru, a second-year fellow from Pune, and Priya, who works with the recruitment team for Teach for India. We have Shweta from Noida. Yeah. So, okay, the screen is working right now. So Rahul, Rakesh, you can take over from there.
Okay. So I will start from this. So today is what I want to introduce to you guys without going into too much of technical detail. What does it mean to have AI, and why have we started speaking about artificial intelligence at all and in 2018 or 19? In fact, it's not a new term. We have seen it in movies and such and so forth. Can I go to the next page? How do I control this? Yeah. So,
okay.
Yeah. So today, briefly what I will talk about is introducing what is AI and the history of it. How does an artificial intelligence learn? And we are going to see some examples of it, and in the context of the future, what it holds for us and artificial intelligence in a world with artificial intelligence, which is as common as it is. Let's go to the next slide. So if you like, even if you are not a movie buff, you might recognize some of these from the posters, like Terminator, or recent movies like artificial intelligence, or the Blade Runner. In movies we have seen continuously some AI being portrayed as either something very harmful, or something that doesn't understand human emotions, or something that is like, a sort of like an AI overlord that you saw is like, somebody like Jeff Bezos was trying to explain to us that it may not happen. So when we have these kind of perceptions of artificial intelligence from the movies like Matrix or Terminator, it's very difficult to separate the facts from the fiction. But today, AI is actually all around us, even if we don't know it. If we go to the next slide, can we go to the next slide, please? Yeah, so this, you will see that there are thousands of news articles. Even if you do not go for technology news, if you go to any of the websites or news outlets, social media sites, there will be one or the other news of AI popping up in front of you. Sometimes you might not even recognize it. You might think of it as some assistant like OK Google. If you have Android phone, you can speak OK Google to you, and then something will recognize that you have said that and will try to respond to your commands. When you go to some of the bank's websites, including either SBI or even sometimes Swiggy, or like some of the most common websites, you chat with bots all the time, where you try to resolve your problems by typing in what seems to be your problem. And at some point, seamless transition happens when some actual human being comes into the chat. But up to before the human being comes in, all you are conversing with is an AI. And you have all heard of things like data analysis, big data, or you might have heard of other kinds of things like let's say deep learning. These have become buzzword in today's world. Everybody does either there are apps on your phone which does face recognition, there are apps on your phone that does voice recognition, fingerprint matching. All of it has, to a certain extent, originated from technologies that we developed along with AI. And this is what I will try to impress upon you today, that things that we think that in future are actually here. In fact, some of you can remember the movies like Minority Report. Minority Report, I don't know how many of you remember that Tom Cruise movie, where where the government could predict crime based on like certain algorithm, and it could see somewhere in the future who is going to commit the crime next. That seems like a very big science fiction fact. Do you know in New York County Police Department used some program which is very similar to what my Minority Report talks about just this year? So AI is all around us, and it's happening right now as we speak. And so we need to understand that what's going on with all of us. Next slide, please. Next slide. Yeah. So this is from IBM's website. If you go search for IBM Watson, this is one of the screenshots. Like this is on their front page I have taken. They talk about something called Watson Assistant, and it's something that you can download today, and you can build your own friendly neighborhood artificial intelligent assistant. You can buy it from them just today itself from their website, and they project that by next year 85% of all customer interactions, all retail interactions will be handled by AI. And this is not something new. They in fact restructured IBM, such a company which only used to make this big hardwares or computers, or or something like your graphics cards in your laptops. it has restructured its entire research and development team to focus on artificial intelligence since, since 2007. And something very magnificent happened in 2007. This name Watson or Watson Assistant comes from IBM Watson. IBM Watson in 2007 won the game of Jeopardy against human participants. And it was a monumental change. It was if you guys know about Jeopardy, the game show, it's not about answering questions like you do in a quiz. But if you are given an answer and you have to construct a question based on that. Let's say if in Jeopardy you are given the phrase Mount Everest, you are supposed to say what is the tallest mountain in the world. And an AI beat human participants, and not just participants, all the 10 previous champions of that game in the game of Jeopardy. And following that, and that was developed by IBM, following that, IBM has gone into the path of building an AI technology that they want almost at every kind of business, entrepreneurial, any kind of collaborative work, including teaching, education, health, everywhere. And this is just one of the futures that is in store for us with AI, and that's the big picture. So called. We'll go to the next slide, please. But artificial intelligence research dates back decades. In fact, 1952 was some of the first AI's mathematics was developed that still powers some of the artificial intelligence application that we run today. But what's changed right now? To see that, we'll go to the next slide. Next slide, please. So if you have seen that now there are three things that have happened. One of them is that we have much larger data sets available. We have digitized almost everything about the world. We collect a lot more data right now. It's not just CCTV, it's not just your phone traffic. Amazon employs engineers to just look at the buying traffic. If you are aware of some of the what the engineering jobs in Amazon entail, is looking at the traffic of buying, what people are buying at every point of time. And then we have developed technology to easily collect and store the data. And we have also improved technologies on graphical processing units. You have heard of CPUs. Previously, we only used to talk about your computer. We used to talk about the RAM, and we talked about whether you have 2 GB, 3 GB, or 6 GB RAM, and that was all CPU based. But we have developed these graphics processing units which can massively parallelly do operations that CPU was not capable of doing. And the evolution in GPU technology has happened over the past decade or so. And then you have new improved softwares that have come in. TensorFlow, if you know, Google distributes it freely. You can build your own AI with just a little bit know-how, and they actually tell you how to build your own AI. That TensorFlow software actually runs on those graphical processing units in your laptop or on your computer. You can yourself be an AI expert if you decide to put some time into it. And that accessibility and the advance on technology that has made AI solve problems that we thought AI would never solve before. In fact, if you know that you know that you can do Google image search. If any image that you have, if you have an image, you can right click on it on your computer and you can ask Google to search that image, and it finds a similar image or finds the label for that image. You can try it out right now on your browser. If you have an image open, you can right click and try to search for that image on Google, and Google will put a label on it. And behind that, there is some certain AI technology or machine learning algorithm that is involved. So we are going to the next slide. So this is to a certain extent, we are going to talk about certain technical terms interchangeably today. But overall what we are talking about is artificial intelligence. That's the big idea. And within artificial intelligence, there is a subfield called machine learning, which takes care of how to train your artificial intelligence. Like if you want to build something, you need to somehow teach the artificial intelligence with the help of either examples or rules, what say you. But within the machine learnings, there you can put in rules or no rules. There are two kinds of systems that artificial intelligence systems use. If you are using rules, those are called expert systems. And if you don't want to use rules, you just want them to learn through examples, then you use something called neural networks. And let's go to the next slide. So now let us talk about what AI is. We'll come close to that, trying to define it. We know that to a certain extent, because the word intelligence is attached to artificial intelligence, it is somewhat related to how we are trying to build almost like a machine that thinks, right? Now, there is a relation of artificial intelligence and cognitive science. You know that cognitive science also has recently come to fore about trying to talk about how human beings think. It's a very interdisciplinary subject. It tries to get all inputs from all the different disciplines, ranging from philosophy, from linguistics to computer science and physics and mathematics and computer science to come together, and psychology to come together into understanding of human mind. But the relation between AI and cognitive science is the relation between, say, birds and the planes that we develop. When human beings first decided that we would try to fly, we thought birds as a model, right? Even if you see earlier models, the planes were built on flapping the wings like birds would do. That did not really succeed. But we succeeded by understanding the principles of aerodynamics that let the bird stay afloat. And we used part of that in constructing a plane. All the planes also have so-called wings, so-called, but they don't move nowhere in like the birds do. And that is, to a certain extent, the difference between AI and cognitive science. AI can take inspiration, like aeroplane took inspiration from the flight of the birds, at least the gliding part, and some of the propelling part. Those principles it took from the birds and tried to create something new. Similarly, artificial intelligence is trying to build an intelligent system above everything else. So the AI's commitment is to design intelligent system or artifacts that mimic humans or other intelligent beings. And the cognitive sciences commitment is to understand intelligence, primarily human intelligence, by employing different kind of formal or empirical methods. Let's go to the next slide.
Rakesh, Akshay has a question. Are there any theories in understanding neural networks that can be used to understand human networks?
Definitely. We are going to come to touch briefly upon that later in the slide, because neural network is kind of something central to my talk today.
Yeah. And quick time check, it's 5:50. We have 25 more minutes.
Okay. Yeah. So there are different approaches to artificial intelligence that that this table actually is taken from one of the classic textbooks of AI by Russell and Nordvig. That there are 4 kinds of approaches. He makes a distinction between thinking humanly versus thinking rationally, and acting humanly versus acting rationally. But the understanding is that if you think rationally, we always don't think rationally, or always we don't do rational things. It's not to say that there is unstable thinking or something like that, but we prioritize things differently. We have different priorities based on which we take different kinds of actions. And so thus, there are these 4 cardinal axes to understanding artificial intelligence and its actions. Is to which way do you want to go? If you want the AI to act humanly, it has to make similar kind of errors in judgment. Like if it is a low light, it may think of a rope as a snake, like humans sometimes do. It can have phobias and fears. that is not always like acting rationally. So like we'll go to the next slide. So this is where I will like to ask like some couple of questions and ask your thoughts about that, all of you who have joined. So for instance, reflex actions. First question is such as flinching from a hot. Is it rational, or are these actions intelligent? Like I hope
participants, please feel free to type your answers there.
Yeah, please.
Yeah. So Gomes is saying yes, Seja is saying yes, Prerna is saying rational, Shweta is saying rational, Ankit is saying rational, Meenu is saying rational.
So, but is it an intelligent action? It's a so one of the things I want to talk about, rational thinking. Somebody said neither.
Yeah,
okay.
Crystal is saying that.
So, the point is that for rational thinking, by the way, just to give you guys a hint, that to have rational thinking, you have to have a choice. If you touch a hot stove, you will immediately take your hand away. There is not much choice there, right? You can't will your mind to not flinch from a hot stove. You may have, like, after a long deliberation, okay, I will touch it now, but you're going to flinch nonetheless. And if you are willingly take your hand to the stove, mind you, that's not a very intelligent action either. But like, this is to demonstrate to you that what is rational thinking versus rational thinking requires certain deliberation. There are stages. If you know this is reflex actions do not come from our central nervous system. Reflex actions come from, most of it comes from our spinal cord and the nervous system within. So there is not really any any thought that goes into it. It's something that we are programmed to do. Like the computer, if you click on some button, something will happen. This is also like that. This is not a rational action. I want to put that there. It is probably an intelligent action because that's why we have evolutionarily kept it. But still, it is not a rational action. And then, like, the next question is slightly easier. How could introspection or reporting on one's inner thoughts be inaccurate? Would I be wrong about what I'm thinking? This is again, like, this is slightly easier. But this is connected to the previous questions.
Yasin is saying rational.
No, this is not about rational. I'm just saying
subjective. He's saying subjective.
Can be like, can you be wrong about what you yourself are thinking?
Yes, you can be wrong, is what Akshay says. Rahul says due to biases. He's asking a question. Om says yes, we can be wrong. Shweta says sometimes. Meenu says yes.
You see that, like, to a certain extent, that to be a thinking being, you have to be able to think about your thoughts. And sometimes when you try to think about your thoughts, you may end up thinking that, okay, yeah, you might be wrong about what you were actually thinking, right? But this is actually a cornerstone. This question is connected to idea of artificial general intelligence. An artificial general intelligence system should be able to think about its own thoughts, should hello?
Rakesh, we can't hear you.
Hello?
Yeah, we can hear you now. Yeah.
So I'm saying that how can you be, so one of the key points about understanding artificial general intelligence, we need to understand that we need to think about our thoughts, and the artificial general intelligence system needs to do so as well. Let's go to the next slide. So, and what are the like, why are there so many AI problems? Why are there so many artificial intelligence problems? Because of something called combinatorial explosion. This is a simple way of thinking about, let's say, a game of chess. You have many starting positions. For each position, like what you will play with, let's say first you will start with a pawn or a rook or a or something like like your night. Depending on what your initial choice is, you are going to have many other options opening up in front of you. If you had to actually think through even 4-5 steps ahead, there will be millions and millions of possibilities that you need to calculate. And most of the times we face in everyday world this specific sort of problem, which cannot be solved with just brute force method, that I will go see what all of these actions lead to in the end. Nobody who is playing chess initially can think of what the final final state of the board would be. After some point, you might have possibilities decreasing depending on how well you play. But what we still amount to is that there are there are branching paths, branching possibilities that we need to take care of. Next, please. So this is this is just for you guys to see on that artificial intelligence is not new. There are several different kinds of, even from the ancient Greek times, we had certain kind of ideas about how we think, and those laws, trying to put them artificially even in terms of logic, was itself a step towards artificial intelligence. In fact, quite a lot of systems that run on the older basis of symbolic logic are still in operation right now. And the ideas of combinatorics, the ideas of building something mechanical but it will act rational. Somebody can look up the mechanical duck. If you guys have time, you can look up the mechanical duck that people made back in 17th century. And mostly what we talk about the advent of artificial intelligence is the last item in 1900s, when we talk about Turing's universal Turing machine and Shannon's information theory. You have heard of Alan Turing, at least there was a big movie about it a few years back. The idea is that all of the computers that we are operating on right now are universal Turing machines. What does Turing machine mean? It's able to do, Turing machines are something that can do any kind of operation, that can conduct any kind of logical operation that you give it. And computers are just that. It's doing certain logical operations, converting all the things that your clicks or your typing words into some logical code symbols that it understands. And also, beginning of artificial intelligence is also Asimov's 3 laws of robotics, Isaac Asimov's novels, and there are terms like cybernetics that were spoken about in 1900s, and those are some of the simple things that started the ideas of artificial intelligence. Let's go to next thing. Yeah, but modern AI has come a very long way. The first one of the first artificial intelligence system was Perceptron in 1958. And now we have systems that are so big that their companies are being bought and sold at almost $500 million. There were some few scientists working in one single lab. We have come to very large scale companies. In fact, if you go to ImageNet or thing like that, you will see that there is a competition called ImageNet held every year, and it's something in ImageNet competition was won by AlexNet, one of the deep learning systems, in 2012, and that's when all the interest in AI came back. There was a very awkward silence, or what is called AI winter, between 1970s to 1995, because our systems, our technology was not able to catch up to what we wanted to do. What was needed for artificial intelligence was a large amount of data and large amount of processing, which did not happen until late 1990s. Now let's go to the next one. So there are these now we are talking about different kinds of AI, and we need to train an artificial intelligence, right? Artificial intelligence starts off like a tabula rasa. It's sort of like an empty slate. But we need to teach the artificial intelligence what we want it to do. It can learn by two-way conversation with the user. It can learn by being told what is true. It can learn by being shown examples of what they are required to interpret, and also by actively interpreting their environment and learning from what they find there, or by logical reasoning from what they already know. All of these different methods of learning that they have been gleaned from the way that we teach a child, or teach somebody like, who speaks a foreign language. That might be a better idea. That sometimes we have to teach a child, like first learning that a child does is ostensive, just pointing towards something like that's a ball, that's an elephant, or that's a desk, that's a cat, that's a dog. And some of the AIs today are built on even that principle. You show a lot of examples and tell them what that is. Give them that label and see whether they can generalize from just the example given to something new. Let's go to the next slide. But we also need an element of uncertainty. Uncertainty is a key idea that we have to build into our AIs. In order for an AI computer program to execute its instruction, the order needs to be unpredictable. And the solutions also. Solutions sometimes need to be unique. If they did the same things as we taught it to do, then it will never do something new. Let's go to the next one. Now we are going to come to one of the examples of artificial intelligence and how we make it learn without going too much into technicalities. So artificial neural network is neural network is an information processing system loosely based on the model of biological neural network, that is our brain or our spinal cord, and it's implemented in software or electronic circuits. The idea is that it has simple building blocks, and how well they're connected, that determines what that neural network can learn or how it is able to learn. And it must be able to learn, and it must be able to generalize. Let's go to the next slide.
Rakesh, quick time check. We have 10 more minutes and then we'll take some questions.
Yeah.
Okay.
I'll go through quickly. So if you know that neural networks are inspired for human brain, there are like more than 10 to the power 11 neurons in the human brain. And the learning for human brain is forming new connections between neurons or modifying certain existing connections. And that is exactly the model that neural network learns from. Let's go to the next slide. So if you see a biological neuron where the incoming connections come from, and the axon that carries the connections to a different bunch of different neurons, that is the principle we use to build the first artificial neuron, that is Perceptron, where there are certain incoming connections and that gives certain kind of output. Let's go to the next slide. Let's go to the next slide. We'll skip this some of the technicalities. If somebody is interested, I'll go into a bit more. Let's go to the next one. So this is a simplified perceptron where some of the like incoming connections that are coming in, you sum them and threshold them. If the sum exceeds certain threshold, only then there is an output, otherwise not. It's like the neuron states of firing or not firing. If the neuron chooses to fire, that is the state called on, and if neuron does not fire, then it is off. And this simple classification can be extended to generalize and learn different problems. Let's go to the next slide. The training artificial neural network, including perceptron, starts from position of complete ignorance. So during training, the novice machine is shown examples of what it must learn to interpret. That's the training set. And associated with each of the training stimulus is the target or the right answer. And this is, again, perceptrons learn through what you call supervised learning. Let's go to the next slide. And if the output of the perceptron is correct, then you don't do anything to it. If the output of the perceptron is on, but it should be off, then we decrease, we change the weights of the perceptron until it gives the correct output. Similarly, from off to on. And this distribution of weights, so it doesn't learn a rule, but it learns a distribution of weights. The answer, the correct answer is embedded in how you train it. So let's go to the next. So for instance, if we had to learn, like an AI had to distinguish between dogs and cats, it will learn through a bunch of different examples about their size and how well they are domesticated. Let's say only on these two axes, the job of an AI would be, or a perceptron would be, to given these two, draw a line between the dogs and the cats. And that's like, if it sees dogs, the neuron state should be on. If it sees cats, the neuron state should be off. The point is that to adjust the weights until it does so. Let's go to the next slide. And we'll skip some of these. Let's like if somebody is interested, I'll come back to that. The idea is that we cannot overgeneralize. If you know that there is always, given a set of data, there is your training set. If you try to fit it too perfectly, then you lose the ability to generalize. There is a principle of push and pull involved. Like if you see the third graph over there, that fits, the third graph fits the examples more perfectly, but it will make more errors in the long term. Whereas the graph in the middle does not fit as nicely as the third one to all the examples, but it will make less errors in the long term. And the first one is underfitting because it does not capture the pattern of the data at all. And when we deal with AI, we have to always take care that we don't overfit. So we don't make our artificial intelligence system like a perceptron to fit too closely to the training data. If there are some errors, it's fine, it's tolerable, which means it can generalize. Let's go to the next. And from neurons, we go to, like now we can build all these different perceptrons together into very large scale networks. Although now the neurons have modified into something else. What percentage of error is acceptable, somebody is asking me. So the percentage of error depends again on trial and error, how much you want to generalize. The percentage is decided based on, you want your neural network to do well in the training set. What we try to do is, that's why we have something called a method of cross-validation. Cross-validation is you separate the data into multiple different chunks, and you take one part of the part A as training and rest of it for testing, how well it generalizes over that. Then you take another chunk as training and see how well it generalizes over the rest of the data, and see how it handles newer and newer examples. The idea is simple, that the percentage, we want it to be at least 80, 85. We'll see that benchmarks given everywhere. We need to be above chance level. That's all we can say. Above chance level is as good. As far away we can go is better. But if it matches 100% to just the training set, it will never do well in generalizing to complex problems for when the new data comes in. Let's go to the next slide. Have seen there are deep neural networks are built not just with those neurons in one single layer. Now we add hierarchically layers of neurons, more complex structures, more complicated connections, and thus it's able to do all the image recognition and image labeling that you see in Google. It's built on top of the similar architecture we saw. Each of the units in each of those boxes that you see above, there are multiple different multiple different, sometimes tens or thousands of units in each of those boxes. Right, so let's go to the next one. I hope I'm not missed any question. Now we'll talk about some of the failures of AI before we go into talking about the future. You have seen, this is from, again, Russell Nordvig, one of my favorite books. If somebody wants to learn basics of AI, it's a very thick book, but very easy to read. Like it's in David Lodge's Small World, a novel about academic world of literary criticism. The protagonist causes consternation by asking a panel of eminent but contradictory literary theorists the following question: what if you were right? None of the theorists seem to have considered this question before. Similar confusion can be evoked by asking AI researchers, what if we succeed? And we'll see what happens when we succeed. In the next slide, please. This is a news item that came out very recently. The University of Maryland researchers created more than 1,200 questions where they tested the AI and human participants on similar questions, and where they just changed the keywords that the AI was using to find the answer to something related. Like instead of saying a proper name like Carl Ferdinand Pohl, if they had said the archivist of Vienna Musikverein, then the AI failed to answer the question, whereas human quizmasters could. This again is a failure of AI. To understand semantic information and connections to the level that we understand in human language is still missing in AI. Let's go to the next one. And also, like for instance, I was talking about New York County. In North Point, they built a crime predictor based on AI, which disproportionately marked Black residents as possible offenders. Similarly, we have seen the results where Tesla autopilot led to death of a passenger in Florida. And talking about learning by conversation, Microsoft introduced a chatbot called Tay last year or earlier this year on Twitter, trying to learn from massive amounts of examples of all the human Twitter. And they, like the chatbot turned into a Hitler-loving feminist bashing troll within a day. It was a day of examples of Twitter, and the chatbot turned into this. And also, Chinese government is doing its nefarious purpose AI facial recognition, which you guys can read all about at your own time. There is a link provided in the PDF. Let's go to the next slide. But there are some heartening tales also. If you go to one of our colleagues in University of Toronto, she had invented something called marketable AI, trying to understand what clothes you need to buy so that you are fashionable for a particular city, particular weather, particular time. Now an AI can help you. It's again an AI assistant that solves the problem that some of us have. If anybody goes to my social media, will see how fashion challenged I am. So similarly, I think people suffer from this. But an AI assistant can help you understanding how to buy, what to buy, including your budget, and what is fashionable given the region that we are in. And AI is used to understand that. That is very interesting application. Next one. And there is a very interesting website called deepart.io. If you go there, you upload a classical painting. Like for instance, if you see bottom left corner, Van Gogh's Starry Night, and you want any picture to be drawn in that style, you can upload two pictures. One classical painting like the Scream or the Starry Night, and another picture you want to be drawn in that style. And this application uses deep learning and AI technology to separate the style of the art from the artist's painting and apply it onto any picture that you have. And it produces some really cool looking eerie images that you can ever see. Let's go to the next slide. I think we are nearing the end. So this is a question that quite a lot of you have asked me I saw in the Google Forms, that where is the place for AI in education? There are few, like you guys can yourself look up a Watson assistant, which can help you in automating certain administrative tasks, whether that is a viable option. But more importantly, I feel that there is a collaboration between human and AI can solve certain challenges that we face in today's world, where we are trying to teach a more diverse population now, that as opposed to a century or even 50 years ago. But students, let's say, like, how can we convince our students to make errors? How can we go to something like how can we ask a kid to have make more errors by having an AI assistant work alongside it? sometimes children are intimidated, or like even students, older students are intimidated to just make errors in the classroom. But something like that can be made easy if they can just they converse with an AI, and that AI can lead a way to offer a more differentiated and individual-based learning. Because we all know that everybody learns differently, but if you can have a faceless assistant AI sort of, sometimes it can make actually the changes are being made in the educational system, at least in certain parts, to treat autistic or children with learning disability by trying to cater a learning method that suits them. And how do you decide on that? How do you decide in a big classroom if everybody has a personal AI assistant in either a tablet or a phone? That can be made easier, and that can lead to true collaboration between human and AI. Go to the last slide. I think I have. I'll just end.
Okay, yeah, and then we can take some questions.
Yes.
Okay.
So yeah, the point is that AI is here to stay, and it is part of our daily life, even if we don't know it. And thinking in AI is also thinking of solutions, and requires us to take stock of what it means to be human, and trying to we would like to stop thinking about all the Terminator-like scenarios, and probably try to think where we can apply AI at the end of our what we say, at the horizon of our humanity. The point is not that AI is going to take the jobs from us. It's very easy to fool an AI, even right now. AIs can't and the tasks that already human beings can do, most of it's not going to be replaced by AI. But to really integrate it into our lives and learn it, is to take a stock of our limited humanity. And start thinking of our limits seriously. That's where I would like to stop.
So we have some questions. First is, how can the quality of AI be judged?
So AI's quality is judged based on what kind of task you want it to do. Like basically, if you want it to label an image, you want it to label correctly. If you want an AI to pick something up based on if it is circular or cuboid, then you judge it on that performance. The point is that the quality of AI is judged only on the basis of the purpose, and then I hope that there are other kinds of other questions that people can ask me.
Yeah, so we have some questions based on the form that you've collected. So first one is, if you consider computers as infants, do you think they'll soon learn to be conscious on their own, just like we teach human babies?
The computers actually are not even like human. They are like bricks for me. Computers don't. Computers still are a tool. There are certain things in it, for instance, Microsoft puts in Cortana, used to put in Cortana. Apple puts in Siri, and Android systems have their own assistants and such and so forth. Some of those parts are try to you can have to a limited extent some interaction with. But overall, computer is not even like an infant. But AI system, even now, the best AI systems available, even if they do some tasks much better than human beings, we are unable to generalize it beyond the kind of task, right? And somebody's asking, what is deep learning?
Deep learning, yeah.
Deep learning is what we saw towards the end of my Perceptron presentation. Deep learning is basically making massive numbers of those perceptron-like, not exactly perceptrons, but those neurons who arrange in layers like a hierarchy. In our brain we have layers, right? Our brain actually cortex, the neocortex that we use, that has 6 layers. So at each layer, so you can have from say for instance, when the information from our eyes goes to our brain, the early visual areas separate the only very little information. Are there edges? Are there let's say are there lines oriented at 90 degree, 0 degree? And what is the contrast like? But as you go higher and higher in areas, like when you come to your prefrontal cortex, you know the name of an object. So deep learning is built on same principle. So you start with very low level features of images. Its main application is still now only in computer vision, is that you have images where you learn smallest low scale level features, and at higher levels you can learn about an entire object and you can label it, and you can do it sometimes without supervision. And that is basically deep learning. Deep learning they can generalize across huge amounts of data. To train a deep learning network is to train it with 1 billion images. Mind you, we did not have that firepower before. 1 billion images. We could not do that before, so we did not have deep learning. All the technology was already there. Nothing new, by the way. You see specialized jobs that would require higher skills. Of course, the examples that I showed you are just at the cusp. For instance, the deep art, the idea that you can, to a certain extent, now think deep art, that neural network creates images based on styles of old masters. But does that eliminate the cause for creating new style? Where do you go if you want to create a new style? Neural network can't give you that, but you need a specialized job already. Some of our jobs need to be more specialized so that we go beyond all the things that we can do and focus on what we really want to do.
We have another question. So how can people, especially teachers, introduce AI to students to explore it as a field of study?
There are some of the very interesting things that you can do is that try to see their applications of the simple mathematical problems, like even equations, right? So perceptron learning, this is something that I haven't shown. You can have a perceptron to learn, to make simple distinctions between images, but those all are basically, you will see their equations of lines or planes. Simple equations can be used to learn something more complex, learn something more general. And I think that is the draw of it. And also it allows you to think about how we think, how we learn. And putting AI into a classroom of AI and computer science, people say that it should be part of any sort of curriculum, because there is, at one point you have to think of any of the traditional problems that you see. Can you put it in different terms? Let's to give you an example. What I want to say is that, let's say you have a simple thing like how do children solve mazes, or you give some mazes as example. What does it require? What does it require for everyday problems to be solved that we are doing continuously? And that an AI can really help to point out, like we have actually AI to simulate how we will look for the actual solutions to some of these problems. And that can be very useful.
Okay, so what are some specific applications for AI and machine learning in ed sector?
Like I said, there are things that you need automatized. Yes, you can use you can use AI to automate almost every task that you find mundane. Like simple things like, if you put an AI application like Watson assistant, you can tell it to check your papers based on certain keywords. It might make some errors, but it will give you the things that you need. But you need scheduling. You need to take care of multiple different kinds of tasks, which cannot be done, which you spend a lot of time on. And AI can do very well, especially the tasks that require probabilistic thinking. I was talking about our limits. One of the things we are not at all good at is using probabilistic thinking. If some of you can look up the Kahneman's Thinking Fast and Slow, you'll see multiple different examples where we as human beings completely fail to understand probability. Like people give very weird answers. Even people who teach probability give weird answers to problems on probability, because we as human beings, we can issue relevance. We can find what is the priority, but we can't use it to understand probability. And wherever the task requires probability, understanding large scale, this thing, large scale data that you need to go through, parse through, understand what is the cause and effect, maybe you can use AI.
Okay. Akshay is again asking, like, are there any theories in understanding neural networks that can be used to understand human networks?
Neural networks use all the theories of human networks. Like the kind of the learning that I showed for Perceptron is called Hebbian learning. It was first understood by Dr. Donald Hebb back in 1940s, and he used that to understand how neurons form connections in our brain. That if two neurons fire together because of something, then the connection between them will be strengthened. If the neurons fail to fire together, then the connection will be weakened. And that is the exact principle that perceptrons use. We have just quoted that Hebbian learning into this. And in fact, large scale, you might have heard of Cambridge Brain Project or large scale human brain mapping projects, where we are trying to map large scale brain networks based on similar principles as to a neural network. We want to see now how different parts of the brain connect together and try to learn, and what failures arise from if some connections are not there.
So it's 6:27. Just going to take last one more question, and then we will close out. So what are the kind of jobs which you think will be difficult to automate, or can everything be automated?
I didn't get you. Excuse me.
What are the kind of jobs which you think will be difficult to automate, or can everything be automated?
See, as I said, like anything that requires you to set priority or relevance cannot be automatized. Automation is different from setting priority. If you have to put so you can try to automate a repetitive task. That's fine. But if you have to prioritize, like one of the Tesla's failures, their failures are because they how do you prioritize pedestrians over time, some of those things that appear, which seem very normal to us. We assign priorities all the time, by the way, and we are very good at it. And if we failure to prioritize, then we fail as human beings in our life and goals and such and so forth. And that is very difficult to automate. That how are you going to put? Let's say you have gotten a salary of some X amount. How do you prioritize what to do? How to prioritize between your leisure and your your hobbies versus what is your necessity? It varies from every month to every month. AI can't do that. In fact, the largest scale hybrid AI that IBM has built, IBM's Watson assistant, now I assist IBM in figuring out which companies to merge with or acquire. So they have board meetings, they have board members speak to an AI, because AI can do probabilistic thinking well, but AI can't assign priority to which companies to acquire, which companies to merge with. For that, they still need human board members. So the idea is that AI not as replacement. The idea that I'm slowly trying to put forward, that we need to go towards collaborative AI, not as a replacement of humanity, but there are certain things we are limited at, and we need to complement that with AI.
Okay. Thank you so much, Rakesh, for joining us in this webinar and teaching us all about AI. For the participants, we have sent our feedback form. Please fill that feedback form just for us to understand what we can do better. Rakesh, would you like to share something about the webinar? Any feedback, any thoughts?
Yeah, no, I have had a very you guys all have been very accommodating, and I have been a bit of a mess, and I fell sick in between. You guys were very understanding. I am I really thank all of you and all of the people who came to listen to the webinar. Thank you for giving me this platform.
Thank you so much. Yeah, thank you everyone for joining. And the next webinar will be on 21st of August with Isha Matri on microorganisms. So please join us on the next webinar as well. Thank you. Bye.